In how many ways can 5 boys and 5 girls be seated at a round table so that no two girls may be together? So it's a circular permutation concept. Let us assume that so total 5 boys and 5 girls, 10 candidates, and given condition is that no two girls may be together. So first we'll arrange the boys. So let us say B1, B2, B3, B4, B5 are the 5 boys. So and these 5 boys can be arranged. 5 boys can be arranged in a round table in 5 minus 1 factorial, that is 4 factorial ways. Because for circular permutation, if n objects are there, first we need to fix one object, then the remaining objects can be arranged. So if one object is selected, then remaining 4 objects can be done in 4 factorial ways. So this is how circular permutation can be arranged. Now, the remaining gaps we have 1, 2, 3, 4, 5. In these 5 gaps, these 5 girls can be seated so that no two girl is together. Now 5 girls can be arranged in the remaining seats. In how many ways? 5 factorial ways. So therefore required answer is a required number of ways is equal to 4 factorial into 5 factorial, which is option D. A box contain 2 white balls, 3 black balls and 4 red balls. In how many ways can 3 balls be drawn from the box if at least one black ball is to be included in the draw? At least one black ball. So here total 2 white balls are there and 3 black balls are there and 4 red balls are there. So total 2 plus 3 5, 5 plus 4 9. So 9 balls are there. And now the question, 3 balls be drawn from the box if at least one black ball is to be included. Let us consider among the 3. So this 3 can be taken as one black ball and 2 other balls. Means other means either white or red, or 2 black balls, one other ball, and or we can say 3 black balls and 0 other balls. So these are the possibilities we can have. So one black ball means out of 3, one to be selected, that is 3C1, and the remaining 4 plus 2 6 are there. So 6C2, two other balls to be selected from the other. So 3C1 into 6C2 or means plus, and 2 black ball, that is from 3C2 into 6C1 or 3C3 into 6C0. So we can write 3C1 value is 3, 6C2 value is 6 factorial by 4 factorial into 2 factorial, and 3C2 value is again, and we have the NC naught is equal to NCN is equal to 1, NC1 is equal to NCN minus 1 is equal to N. So we can write here 3C2 value is 3C3 minus 1, that is 3, into 6C1 value is 6, and again 3C3 value is 1, 6C0 value is again 1. And here we can write 3 into 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial is 2 into 1, so that we can cancel and write here 45. This is so 45 plus 18 plus 1, so we can say 45 plus 18 is 63 plus 1 64. So we can say the number of required number of ways is 64, which is option A. In how many ways can 5 prizes be distributed among 4 boys when every boy can take 1 or more prizes? So here total 5 prizes are there and 4 boys, and it is also given that each boy can take 1 or more prizes. Means only one boy may receive all the 5 prizes also. So first prize may be assigned to any of the 4 boys. So first prize can be distributed in 4 ways, and second prize similarly for 4 boys we can say 4 ways. Third prize, it can be distributed any of the 4 boys, that is 4 ways. Similarly fourth prize and fifth prize. So required number of ways of distributing 5 prizes among the 4 boys can be taken as 4 into 4 into 4 into 4 into 4, that is 4 to the power 5, or we can write 2 to the power 10. 2 power 10 value is 1024, which is option A. We need to find the number of positive integral solutions of product ABC is equal to 30, that is A into B into C. So 30 can be taken as, so we can write A into B into C is equal to 2 into 3 into 5. So these are 3 different prime factors. So 2, 3 and 5, this 2 can be assigned to any of these letters A, B, C. Similarly 3 can also be assigned to any of this ABC, and 5 can also be assigned to any of these 3 ABC. So each prime factor have the possibilities to assign the letters is 3. So we can say the number of positive integral solutions is given by, so 3 into 3 into 3. So these 3 possibilities are for each prime factor to assign ABC. So total 27 ways are there. So which is option B. If 20CR is equal to 20CR minus 10, then find the value of 18CR. So we had property NCA is equal to NCB, which implies that either A is equal to B, or we can write A plus B is equal to N. So here we can use 20CR is equal to 20CR minus 10. So we may use R is equal to R minus 10 is not possible. So the second case we can say r plus r minus 10 is equal to 20. That is 2r minus 10 is equal to 20. So 2r is equal to 20 plus 10 30. So r is equal to 15. So r is equal to 15. So we need to find 18cr. That is 18c 15. So we can write 18 factorial by 18 minus 15 is 3 factorial into 15 factorial. Because NCR formula is n factorial divided by n minus r factorial into r factorial. So 18 factorial we can add 18 into 17 into 16 into 15 factorial divided by 15 factorial here, and 3 factorial we can add 3 into 2 into 1. So we may cancel 15 factorial and 3 6 times, and here 2 again, here 2 8 times we can write. So we can say here 6 8s are 48, 48 into 17. So 48 into 17 after calculation you will be getting 816. So 816 is the answer, which is option B. In a polygon, no three diagonals are concurrent. If the total number of points of intersection of diagonals interior to the polygon be 70, then the number of diagonals of the polygon is. We can see very clearly that for any polygon of any sides, for convex polygon, joining any two vertices is a diagonal, and the other two vertices will lead to one point of intersection, which is interior to the polygon. Means combination of four vertices, we can say combination of four vertices leads to one point of intersection. And since it is given total number of points is 70, so therefore let number of sides of polygon be n. Number of sides of polygon be n, let us consider. Therefore n vertices are there. We have n vertices. Among the n vertices we need to select first 4. So among the n vertices, selecting 4 will leads the number of points of intersection. So which is given 70. So NC4 is equal to 70, that is n factorial by n minus 4 factorial into 4 factorial, which is equal to 70, or we can add n into n minus 1 into n minus 2 into n minus 3 into n minus 4 factorial upon n minus 4 factorial is equal to 70 into 4 factorial. So we can cancel here n minus 4 factorial. So n into n minus 1 into n minus 2 into n minus 3 is equal to, so let us simplify here, 70 into 4 factorial is 24. So we can write 7 into 2 into 5, and 24 we can write 8 3s, that is 2 into 2 into 2 into 3. So here 7 is a prime number, 5 is a prime number. So let us write here 7, and the number I can take 6 also. 2 into 3 is 6, and 5 I can write, and the next number 2 into 2 into 2, that is 8. So I can write 8, so which is equal to, so I can write 8 into 7 into 6 into 5. So when comparing both, n is equal to 8, we can say. Therefore number of sides of a polygon is 8. And we need to find the number of diagonals now. We have the formula, the number of diagonals of polygon with n sides is equal to n into n minus 3 upon 2. That is 8 into 8 minus 3, 5 upon 2, which is equal to 20. So we can go with an option A. With 17 consonants and 5 vowels, the number of words of 4-letter word that can be formed having two different vowels in the middle and one consonant repeated or different at the each end. So here these two middle places can be occupied by the vowels, say V1 and V2, and consonants at the end different or the same, so repetition is allowed. Two consonants, so we can write in the middle two vowels. Two vowels can be selected among 5 vowels is 5C2, and again these vowels can be arranged themselves like 2 factorial. So 5C2 into 2 factorial, or we can write 5P2, 5 factorial upon 5 minus 2 3 factorial, so that is 5 into 4, which is 20. Similarly the consonants, and here consonant C1 and C2 can be selected and arranged among 17 consonants, so which can be taken 17 because repetition is allowed. Since repetition is allowed, so consonant, first consonant can be any of the 17 and second consonant also can be any of the 17. So 17 into 17, that is 17 square, which is 289. Therefore the required number of words is equal to 289 into 20, which is equal to 5780. So we can go with an option A. 5780 words can be framed. The letters of the word tough, TOUGH, are written in all possible orders, and these words are written out as in a dictionary. Then the rank of the word tough is. First, let us identify the position of the letters. We can say G is the first letter in alphabetical order, and then H is the second, and then O, and then T, then last U. So let us write the required word tough, TOUGH, and the positions can be taken 4, 3, 5, 1 and 2. And now let us see, by using the shortcut method we can identify. Coming from the left side, below 4 there are numbers 3, 1 and 2. 3 numbers are there, so we can write 3. And below 3 towards the right side we can find only two numbers 1 and 2, only two letters, the positions. And below 5 to the right side we can see there are two letters which are whose position is less than 5, so we can write 2. And below 1 there is no number, so we can put 0, and below 2 also there are no numbers, put 0. And then start writing 0 factorial, 1 factorial, 2 factorial, 3 factorial and 4 factorial. and hence we can say by multiplying correspondingly. So 3 into 4 factorial plus 2 into 3 factorial plus 2 into 2 factorial plus 0 into 1 factorial plus again 0 into 0 factorial. So 4 factorial is 24. 24 into 3 plus 3 factorial is 6. 2 into 6. And again 2 factorial is 2. 2 into 2. And here it is 0 and 0. So we can write 24 threes are 72, 2 6 are 12 and 2 2s are 4. So we can write 84 plus 4, 88. So below before tough there are 88 words are there, and then we can say rank of the word means the position in dictionary order. Rank of the word tough can be taken as 88 plus 1, that is 89. So 89 is the answer, which is option C. Given that 2n plus 1 p n minus 1 is to 2n minus 1 pn is equal to 3 is to 5. So we can say product of extremes is equal to product of means. So from here we can write 2n plus 1 p n minus 1 is multiplied with 5 is equal to 3 times 2n minus 1 p n, and we know the formula npr is equal to n factorial upon n minus r factorial. So we can write 2n plus 1 factorial upon 2n plus 1 minus n plus 1 factorial into 5 is equal to 3 times 2n minus 1 factorial upon 2n minus 1 minus n factorial. On simplifying we can add 2n plus 1, and here we can see that in the left side 2n plus 1 and right side 2n minus 1. So 2n plus 1 is the bigger number, so it can be reduced to 2n minus 1. Like an example, n factorial we can write n into n minus 1 factorial we can write. So 2n plus 1 factorial we can write 2n plus 1 into the next number below number is 2n plus 1 minus 1, that is 2n, and below this number is 2n minus 1 factorial divided by 2n minus n, here n plus 2 factorial into 5 is equal to, so here we can write 3 times of 2n minus 1 factorial upon 2n minus n is n minus 1 factorial. So here we may cancel 2n minus 1 factorial on both the sides, and simplifying we can write 2n plus 1 into 2n, that is 4. So let us write 2n into 2n plus 1, and in the again the denominator n plus 2 factorial and n minus 1 factorial. N plus 2 is greater than n minus 1, so we can write here n plus 2 into n plus 1 into n into n minus 1 factorial we can write, which is into 5, which is equal to 3 upon n minus 1 factorial. So we may cancel n minus 1 factorial on both the sides, and here we can write n and n gets cancelled. So 2 5s are 10, 10 times of 2n plus 1 is equal to 3 times of n plus 1 into n plus 2, which implies 20 times n plus 10 is equal to 3 times of n square plus n plus 2n, that is 3n plus 2. So we can write 3n square plus 3 3s are 9n plus 6 is equal to 20n plus 10. So 3n square plus 9 minus 20, that is minus 11n, plus 6 minus 10 will give minus 4 is equal to 0. So factorization we can write 3n square minus 12n plus n minus 4 is equal to 0. So we can write here 3n So 3n plus 1 into n minus 4 is equal to 0. So from here we can say n is equal to minus 1 by 3 and n is equal to 4. Since n is a natural number, so we cannot consider here, or n can be taken, n cannot be 0. So n must be an integer. So here we can say n is equal to minus 1 by 3 is not possible. So we'll consider only n is equal to 4, which is option A. So option A is the answer. Three integers are chosen at random from the set of first 20 natural numbers. Let us take s is equal to 1, 2, 3 and so on up to 20. From 20 natural numbers, we need to select three integers. Let the three integers be a, b, c, so that their product is a multiple of 3. So a into b into c must be a multiple of 3. So here we can write the sample space, or the number of elements in sample space can be taken as 20 C3, because we need to select among the 23 numbers, that is 20 C3 value, which is 20 factorial upon 20 minus 3, 17 factorial into 3 factorial, which is equal to 20 into 19 into 18 into 17 factorial divided by 17 factorial into 3 factorial is 6. So here 6 3 times and 17 factorial gets cancelled. So 20 in 19 threes are 57. 57 into 20. So we can write 1140. So this is the total possibilities. And now to get a multiple of 3 from the product, one of, or at least we can mention, at least one of the three integers must be a multiple of 3, so that we can write either it should be a single integer should be multiple of 3, or two integers can be multiple of 3, or all the three integers are multiples of 3. And multiples of 3 are, so multiples of 3 are here 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6 are 18. So totally there are 6 multiples and remaining 14 are non-multiples of 3. So our selections can be, first among the 6 multiples we need to select one, and the remaining two numbers, two integers, can be selected from 14. So 14C2, or another possibility, among the 6 multiples of 3 we can select 2, and then the remaining element can be non-multiples, that is 14C1. And third case, among the multiples of 3 we can select all the 3, and from non-multiples we can select like 14C0. So 6C1 is 6 into 14C2 value 14 factorial upon 12 factorial into 2 factorial plus 62 value is 6 factorial upon 4 factorial into 2 factorial into 14C1 is 14 plus 63 value is 6 factorial upon 6 minus 3 is 3 factorial into 3 factorial into 14C0 value is 1. Let us simplify and write here. We get 6 into 14 factorial, we can add 14 into 13 into 12 factorial upon 12 factorial into 2 factorial is 2 plus 6 factorial can be written as 6 into 5 into 4 factorial upon 4 factorial into 2 factorial is 2 into 14 and here plus 6 factorial, we can add 6 into 5 into 4 into 3 factorial divided by 3 factorial is 3 into 2 into 1 into 3 factorial into 1. So here 12 factorial gets cancelled, 4 factorial, and here 3 factorial, and also 2 7 times. So 13 sevens are 91, 91 6 are, will be getting 546, and here 2 7 times 7 5 are 35, 35 6 are 210, and again here 3 into 2 6, 6 get cancelled, so 5 4s are 20. So simplification will get 500 plus 200 700, 750 plus 76 5 776. So we can write 776 is the possible ways, and hence the chance their multiple of 3 means the probability. Required probability we can write 776 out of, and total it is 1140. So here we can write 4 table cancellation. 4 ones are 4 nines are 36, and again 4 fours are, so 194, and here 4 twos are, and 4 eights are 32, and again 4 fives are, so 194 upon 285. So which is option A? Option A is the answer. If the total number of m elements subset of the set A is equal to A1, A2, A3, A4, and so on An is lambda times the number of m elements subset containing A4, then n is, so here number of elements in the set A is equal to n. So we want m elements a subset, so we need to select m elements out of n. So number of m elements subsets of A is equal to, we can write NCM, because among the n elements we need to select m elements, and here we should not do the arrangements because in set order is not matter. And also number of n m elements subsets containing one element A4 is nothing but number of, we can say, m minus 1 elements m minus 1 elements of a set containing n minus 1 elements, of a set containing n minus 1 elements, because one element is already included, so we will not go with the selection of A4. So A4 is already included, means out of n numbers one number is already selected, so we have only n minus 1 elements. Out of n minus 1 elements we need to select the m minus 1 elements, so we can write n minus 1c m minus 1, so that we can, according to the given question, NCM is equal to lambda times of n minus 1c m minus 1, and we had a property NCM, we can write n upon m into n minus 1c m minus 1, which is equal to lambda times of n minus 1c m minus 1. So here both n minus 1c m minus 1 and n minus c m minus 1 gets cancelled, so we can write here n upon m is equal to lambda, or we can write n is equal to m times of lambda. So the value of n is m times lambda, which is option B. The number of arrangements of the letters of the word banana, BANANA, in which two n's do not appear adjacently. So here the letters of the word BANANA. So we can see that B is repeating only one time and A is repeating 3 times. and n is repeating 2 times. Since we required the number of arrangements, no two n's do not appear adjacently. So let us come to conclusion that let us write the number of arrangements in which two n's are always adjacent. In which two n's are always adjacent. So we need to consider these two n's as a one unit. So we can write n and n as a one unit and the remaining letters b, a, a, a. So we can say total 1, 2, 3, 4, 5. So 5 numbers are there. So we can say here the number of ways we can arrange them is 5 factorial upon. So here a is repeated 3 times. So 3 factorial. And again this n is repeated here 2 times. And again the arrangements can be again done 2 times. Like in inside the bracket it can be done only one way, that is 2 factorial upon 2 factorial. So 5 factorial upon 3 factorial is nothing but 5 into 4 into 3 factorial divided by 3 factorial, which is 20. And now without any condition, total number of arrangements can be given as, so total 3 plus 1 4, 4 plus 2 6, 6 letters are there. 6 factorial upon a is repeated 3 times and n is repeated 2 times, so we can write 6 into 5 into 4 into 3 factorial divided by 3 factorial into 2 factorial. So 3 factorial gets cancelled and here 2 factorial is 2, 2 times. 5 2s are 10, 10 6 are 60. So we can write here 60, but among the 60, 20 arrangements are there with 2 n's adjacent. So required number of arrangements can be given by, among the total arrangements 60, we need to remove this 20 arrangements in which two n's are adjacent. So total 40 arrangements are there in which no two n is together. No two n's together. So option A is the answer. Given NCR minus 1 is equal to 36 and NCR is equal to 84 and NCR plus 1 is equal to 126. So here we can write NCR upon NCR minus 1 is equal to 84 upon 36 and here NCR plus 1 upon NCR, from this both we can write 126 upon 84. And let's use the property NCR upon NCR minus 1 is equal to n minus r plus 1 upon r, and also we have NCR plus 1 upon NCR, we can write n minus of r plus 1 upon r, which is equal to n minus r divided by r, sorry, r plus 1 here. So let us use the property. So we can write n minus r plus 1 upon r is equal to 84, we can write 12 into 7 and 12 into 3. So we can cancel and we can do cross multiplication. 3n minus 3r plus 3 is equal to 7r, or we can add 3n minus 3r minus 7r, that is minus 10r, is equal to minus 3, or we can also write 10r minus 3n is equal to 3. Make this an equation 1, and here second one. So NCR plus 1 upon NCR we can get n minus R upon R plus 1 is equal to 126 we can get 42 3 times and 42 2 times. So here 2 into 2n minus 2R is equal to 3R plus 3. So 2n minus 2R minus 3 that is minus 5R is equal to 3. Or we can just multiply with 2 here. So we can write 4n minus 10R is equal to 6. Say this is an equation 2. Adding 1 and 2, equation 1 and equation 2, we will get 4n minus 3n is n plus 10r minus 10r gets cancelled, and here 6 plus 3 is equal to 9. So we got n is equal to 9, and substituting n is equal to 9 in one equation. So 10r minus 3 into 9 is equal to 3, or 10r minus 27 is equal to 3. So which implies 10r is equal to 30. So we can get r is equal to 3. So the value of r can be taken as 3. Option C.